Okay, so what we're going to do is we're going to talk about the depolarization of a neuron. Okay, so the depolarization of a neuron, just like that animation showed before, what we're looking at is how does a neuron actually communicate, okay, and how does it generate an action potential. Okay, so that's the question we're looking at. How does a neuron generate an action potential? Okay, so it's really looking at how does it generate electricity to be able to communicate and send a message. So what we have here is we have 3 distinct phases of the neuron. Okay, so the first phase is going to be the resting potential. So we're zooming in to an axon. We're zooming into the we're zooming into the axon, okay? And there's 2 things that I want you to know here, okay? First, on the outside, there's 2 ions that are associated with this. The first is sodium. The second is potassium. Okay, you don't need to know the specific charges of sodium and potassium because there's other ions that are associated. Okay, but you want to know sodium and potassium are part of the depolarization or the generating an action potential. Okay, so if you can remember salty banana, sodium's in salt, potassium's in a banana. So salty banana. The other part you need to know is overall, okay, there is a positive charge on the outside and a negative charge on the inside. Do not associate those charges with potassium or sodium though. Okay, and you'll see why in a video. Okay, so the resting potential, what this means is the neuron is ready to fire. So the neuron is ready to fire. So the next part we're going to zoom in on, okay, is again, we're still on the axon, okay, but we want to look at what happens when the neuron's firing, and that's what an action potential is. And this is the actual firing of a neuron. So what happens here, okay, is that we are looking at how is the neuron sending the message, okay? So when we talked about that it goes from the dendrite to the cell body to the axon, how is it actually sending the message? Okay, well, here's what happens. Sodium, okay, there's going to be gates that open up, okay, and those gates kind of look like this. Okay, so those gates, okay, are going to open up, and the sodium is going to flood in. Okay, the potassium is going to leave the cell. Okay, the inside of the cell will generate a positive, or it becomes more positive, it's still negative. Okay, and then the outside, okay, is going to be more negative. Okay, and once it reaches, I think it's negative 55, okay, whatever millivolts, I'm not sure. Okay, once it reaches that, okay, that is called the threshold. Okay, and the threshold, what that means is that's the breaking point. Okay, it has to reach the negative 55. Okay, and once it reaches that, it's going to fire at all or none. Okay, so it fires at all or none. It's not going to continue, or it's not going to half fire. Okay, so let's say when we look at neural potential and you have more intense senses. So let's say I step on a Lego compared to stepping on a marshmallow. Okay, what happens is the Lego is generating more neural impulses. It's not sending them faster. Okay, it's generating more, and there's different types of neurons that are going to be activated. Okay, so that's the action potential. Now, the last phase of the neuron is what's called the refractory period. Okay, and the refractory period is the recharging, and it cannot send another message, so it cannot fire. And what this looks like is I just do like positive, negative, just kind of to symbolize that it's trying to get back to its resting potential. Okay, so it cannot fire in this state. So I can give you an analogy here, okay, that's going to go along with this. Okay, and the analogy is kind of like a toilet. Can everybody picture a toilet? Okay, so I'll bring the video up. Okay, so in a resting potential with a toilet, okay, you walk into the bathroom, the toilet's just sitting there. Okay, it has water in it, it's not making any funny noises. Okay, it's ready to be used. Okay, what happens then, you do your business, okay, and then you have the handle. So now we're getting to the action potential. So the handle is actually going to represent the threshold. Okay, so the threshold, you push on the handle. I can push really fast, I can push really slow. Okay, but once it reaches the breaking point, it's going to fire at all or none. And that firing at all or none is the action potential. Okay, so in this case, what happens is the actual flushing. Okay, so the handle is the threshold, the action potential is going to be the flushing. Okay, then what we have is the refractory period. So the refractory period, I can't get another flush in until the bowl fills back up. Okay, so if the bowl is filling up, it's not ready to go. I have to wait until the bowl is full, okay, and it's in the resting potential before I can flush it again. Okay, so that's another analogy for the phases of a neuron. Okay, so what I'd like you to do is to create an analogy, and you need to think of something that's all or none. Okay, so think of an analogy that you could use, okay, to help explain this. And your table needs to come up with one. I'll give you a couple minutes to do that, and then you're going to share that analogy out.